chapter current electricity. Okay, so electricity, we will be studying electricity, and this is basically for class 10. I guess this is your 12th chapter in the NCERT textbook. So before getting into this chapter, first we need to understand few physical terms like potential difference. Okay? So in terms of electricity, so second we have to understand what is electric charges. What are electric charges? Third, we have to understand about electric current. Okay, and then we will establish relationship between them. Relationship between them. So that basically means first we will understand what these terms are, and then we will try to establish how they are related to each other. Okay, so let's begin with the potential difference. So first we will understand what is potential difference. Okay, potential difference. To start with this, I will not directly delve into electricity, but rather I will talk about the potential difference that you study in your class 9, that is the gravitational potential difference. Then we will draw an analogy, and then we will go back to electric potential difference. Okay? This is the analogy. Okay, because of that, if I have a horizontal surface like this, okay, which is the ground, okay, and then if I have a mass, and I have a mass here, okay, so I have a mass over here, which is at height h1 from the ground level. So this height we are considering to be h1. So then we know that it possesses some energy, which is called a potential energy, and it is because of virtue of this position. Position means, so at this point it will have some energy because of its position, that is the potential energy, and because of that only, if it is supported by something and if it is left, then we know it is going to fall down. Okay, and this potential energy, this gravitational potential energy, is given by mass time acceleration to the acceleration due to the gravity times height. Okay, at what height? So mass cannot be changed; it's a constant. Okay? So the constant g is also having a value of 9.8 meter per second square, or in other words, we can say this one is also constant; it's not going to change. So that means the height is a variable. Height can vary. Okay, so height can vary. So potential energy of, in this case, depends upon what? Depends upon height. Because you see, if I'm going to increase the height, then the potential energy is also going to increase. So then let me make another mass. Okay, another mass m. Considering both of them are having the same mass. Okay, so this is also m, but this is at the different height. So you can see here it is at different height. So this height I'm going to refer to it as h2, and clearly you can see h2 is greater than h1. So potential energy here, so I will write this potential energy here 2, and this potential energy here, which I'm going to write 1 because of h1 and h2. So clearly potential energy will be potential energy here will be greater than potential energy here. Okay, potential energy here. Then then uh, you see, then we can say this to be at higher potential, potential, okay, and this to be at lower potential or potential. So in nature, you will always observe if we are going to leave this mass, they all are going to fall downwards with acceleration due to gravity. Okay, that we know. But the thing out here you have to pay attention to is that this mass out here, okay, this mass out here is never going to go here, okay, without any external support. But this mass out here can always come to this position. Okay, so this position, it can always come to this position. Okay, so that means an object, and in this case, this object, this object can go from higher potential to higher potential to potential to lower potential, lower potential. Okay, potential, potential. Okay, higher potential because this is higher, so it can go here. But this is not possible. This is not possible. This can never go up. So this object will never go from lower potential to higher potential, but definitely it comes from higher potential to lower potential. Okay, so now if we understand this part, so then we can move forward to understand the potential difference. Okay, so let me erase few things out here. Okay, say for an example, PE2, which is your higher potential. Okay, so it is the energy possessed by this object at this height h2 is 10 joule. Okay, and obviously PE1 should be smaller. Okay, so PE1 should be smaller. So I will consider this to be okay. So this will be 5 joule. Okay, so now, so the difference between these two potential energy will be P2 minus P1. Okay, so that means 10 joule minus 5 joule. So which will give you 5 joule. So this is the potential difference. Okay, so but in terms of energy I am talking about. Okay, so anyways, so this will be your potential difference. Okay, so there is potential difference. That is why there is tendency for this object to go from higher potential to lower potential. Okay, now let's understand the more fundamental thing about this part. So when I first said I have a mass, okay, and mass m, and it is at height h1, h1, okay, it's at the height h1, and it has some potential energy. So now we have to understand where this potential energy comes from. Okay, so you all know that everything wants to stay in the ground. Okay, stay in the ground. Okay, so if you are not going to apply force to this mass, it is never going to come to this height by itself. So therefore, this mass is out here because someone did the work. Okay, so someone worked to bring this mass at this height. Okay, so he applied some force, and then there was some displacement so that the mass reaches this height. Okay, so basically work was done, force and displacement. Okay, so this work is stored in the form of potential energy. So and work was done against, see this, there is one force which is trying to pull it down, so that is a gravitational force. So this work has to be done or is done against gravitational force. Okay? Gravitational force. Okay? This work is done against gravitational force. So this work was stored in the form of potential energy. That is how this mass gained potential energy. So you know, if I have to bring mass more up or increase the height, so that means I need to do more work. So then more work means more potential energy. That is why when you increase the height, the potential energy also increases because you need to do more work against the gravitational force. Okay. So now this is your discussion on uh, this one. Okay, gravitational. Okay, so now let's come to electricity. Okay, suppose let me make a charge out here. It's a positive charge, and I have another positive charge out here. So if I have two positive charge out here, they are going to repel. This will repel each other. So that means they will push each other away from one another. Okay, away from one another. Okay, so that is called repelling. Okay, and if I have unlike charges like that, so then they are going to attract each other, attract each other. Okay, so this force. Okay, so basically this force out here, this force out here is called electrostatic or Coulomb force also. So let's talk about the electrostatic force. Okay, electrostatic force. force that exists between two charges. Okay, or sometimes we call it Coulomb force. Okay, now let's get into understanding electric potential, potential difference. Electric potential difference. Okay. So now consider a conductor. I have one conductor out here. Okay. Initially there is no charge. I am assuming there is no charge out here. So no charge out here. And I am going to bring one positive charge into this conductor from infinity. Okay. So now when I bring this charge out here, okay, this positive charge out here, okay. So I do not do any work because why? Initially there was no charge, so that means there is no one which is pushing it or pulling it from this conductor. So therefore, to move this charge, I don't have any force repelling it. So therefore, I do not need to do any work. Okay, so then it does not have any potential energy because potential energy is the work which is stored. Okay, so then there is no this one no potential energy at this point. So now let's consider another scenario. First I've got one charge. Now I want to bring another charge which is also positive in nature. But now to bring this charge, while bringing this charge, this positive charge which is residing in this conductor is going to repel it. Okay, so it is going to repel. It is going to repel. So therefore, to bring this charge, I have to do some external work. Okay, from outside I have to do some work, and that work it is stored in the form of potential energy. So when I bring two charges over here, so the system, the potential energy of the system increase. Okay, so the potential energy of the system increase. So now let's come back to another scenario. Again, when I now want to bring the third charge into the system, so consider this is the third charge. Okay, uh, so then to bring that charge, while bringing that charge, the first is going to repel, and the another charge, the second charge is also going to repel it. So I have to do is more work. Okay, so more work means more potential energy, which is which will be which will be stored by the charges, okay, in the form of potential energy. Now I have three charges in the system, and while bringing each charges more work and more potential, so the potential energy of the system increases as I bring or introduce new charges to the system. Okay, so okay, so now let's remove all these things. So we have understood that to bring charges we have to do work to be, so more charges I bring, more work and more potential energy. So now I will bring another conductor. Okay, another conductor which does not have any charge at all, any charge at all. Okay, so any charge at all. So here I have six charges considered, and here there is no charge, zero. So say there is the potential here will be zero. Okay, and the potential out here will not be zero because some work has been done to bring this charge, so potential will be higher out here. Okay, so if this plate is named as A and if this plate is named as B, so then potential out here can be written as VA and the potential out here can be written as VB. So then this VA is definitely greater than VB because VA there are charges, and to bring these charges we did some work which they have stored in the form of potential energy. Okay, and then we know by the analogy of gravitational potential energy, charges flows from higher potential to lower potential. Okay, so this becomes in that sense this becomes higher potential, and this becomes lower potential. Okay, lower potential. So if I connect these two metal plates of the conductor with a conducting wire, so what will happen? The charges will start flowing from higher potential to lower potential. Okay, so one charge will come here. Okay, so that means one got removed from here. Okay, so another charge will come here. So another one will be removed from here, and one more charge will come here. So one will be removed from here. So now you see that that Now both the conductors have three charges, so what will happen? Both of these plate will have same potential. So that means in this case, VA will be equal to VB, same potential. When both the conductor reaches the same potential, the charges stops to flow, because the charge will only flow when there is potential difference. Okay, so this in which this one you understood what is the need for potential difference, and then okay, and this flow of charge only is known as current. Okay, so which we will define obviously, but whatever the charge which is flowing from this wire, that is only current, and for current is only possibly current, or in other words, flow of charges charges is only possible when there is potential difference. Okay, there is potential difference. Like in the first case, we have some potential difference, but after the flow of charge, when both the conductors having the same number of charge, then there is no potential difference. Okay, but our discussion does not end out here, due to the fact that in nature there are two kinds of charges. Okay, two kinds of charges. The positive charges are also there, and the negative charges are also there. Okay, so I have two conductor out here, So here we have positive charges, and here I have negative charges. Okay, so if this plate is A and if this plate is B, so we can consider the potential here to be VA and potential out here to be VB. Okay, so if this plate A is also having 6 charges and this plate B is also having 6 charges, but still we cannot say which one is higher if they are in the same potential, because of the nature of the charge is different. Okay, if I bring a positive charges between this plate, so it is going to go where? It is going to go in the direction of negative plate. Okay, so that means for this positive charge, this will act like a higher potential, and this will act like a lower potential. Okay, so that's why it is going from higher potential to lower potential, because this charge is pushing it, okay, or repelling it, and this charge, negative charge, is attracting it. Okay, so therefore this, for this positive charge, this is the lower potential, the negative plate is the lower potential, and the positive plate is the higher potential. So, and if I bring a negative charge here between the plates, it is going to go towards the positive, and okay, so because the negative charges will repel it, okay, and this positive charge is going to attract it. So that means for this electron or a negative charge, this positive plate will act like a lower potential, okay, and this will act like a higher potential, and charges flows from higher potential to lower potential. Okay, so see, the scenario are the same, but when we take different charges, the higher and lower potential are different. Okay, so that is, it is relative, so we cannot say directly which one is higher potential, which one is lower potential, without understanding with respect to what we are talking. We are talking about the positive charge, so for the positive charge, the negative plate will be lower potential, okay, and the positive plate will be higher potential. But if we are talking about the negative charge, then this positive plate will be of lower potential, and the negative plate will be higher potential because of the repulsion and the attraction. Okay, so this is for the potential difference, and then if we may now you know this VA and VB are not in the same potential, especially for two different kinds of charge. Okay, okay, so now, okay, I guess in the next lecture we will discuss on electric current. So okay, so this is it.